Alright, so let's say I give you a shape. Let's say I give you a rectangle. Okay. Then I'm going to ask you some things about that rectangle. So I might ask you, are points A, B, and C collinear, coplanar, on line AB, like that.
You're asking
which one of these is correct?
Well, A and B are coplanar, and B and C are coplanar.
But are all three coplanar? It's going to be coplanar. That's the only one that's true for all 3 points, right? So that would be one kind of a question I could ask about this rectangle. I could also ask you which segments are congruent.
Well, then you asked on line A and B.
Okay, so what segments on this rectangle are congruent?
Which segments are congruent?
A and B.
Okay, we've got A, B, and C, D. And A, B,
BC.
and BC. Okay, so you'd have 2 sets of congruent segments on this particular rectangle. I could put a point here and tell you that E is a midpoint. And maybe I label this
Find the midpoint.
hold on, let me make math that works. So I might say E is a midpoint. Like I'm telling you E is a midpoint, and so I'll say find X. What do I know about AE and EB if E is a midpoint? So AE is congruent to EB because of the midpoint. So 4x minus 3 is equal to 9. And so you can solve that to find X. So add 3 to both sides.
It's 3.
Sure is. So 4x equals 12, so X is 3. So when you cross like this, we have 2 straight lines. We have the straight line that's going up and down and the straight line that's going side to side. And so we have 2 sets of angles that can make the side-to-side straight line. That's the 1 and 2 and 4 and 3. Or we have 2 sets of angles that can make the up and down straight line. That's 1 and 4 and 2 and 3. So you get 4 sets of linear pairs. And then each set would add up to 180. So 1 and 2 add up to 180, 2 and 3 add up to 180, 3 and 4 add up to 180, and 1 and 4 add up to 180.
So linear pairs are 2 points that
2 angles.
2 angles that make
a straight line, yeah. And the difference between just straight plain supplementary and a linear pair is that supplementary angles add up to 180, but they're they don't have to be attached to each other. They can be off in space. Like you can have one angle in that back corner over here and one angle up front, but they'll still add up to 180. They're supplemental. Linear pairs are also supplementary, but they're attached to each other. So that's the only difference between like a linear pair and supplementary angles. They both add up to 180, but the linear pair are attached to each other, they touch. And supplemental angles can just be out in the world.
Can you give me an example of supplemental?
Yeah, so like if I have this angle here, and I'm gonna say that's like 50. And then I have another angle over here that was 130. Those are supplementary, because they're gonna add up to 180, but they're not a linear pair, because they don't touch. If they were like this, then they're now a linear pair, because they're attached to each other. So that's the only difference. They both add up to 180, it's just that the linear pair is like attached at the hip. And supplemental angles are like free-spirited and they're out in the world. Make sense? Okay. Anybody writing that down? All right, next thing I might ask you, I might give you a shape. Let me make a better shape. Let's say I give you a shape like that. And I have and I might say angle A is right, acute, or obtuse.
Cute.
It's acute. And angle C.
Obtuse.
So be able to see that and picture it. I might have
And why is angle C obtuse?
it's wider than 90.
Okay.
Yeah. I might have something that says okay, and maybe I labeled a picture. Hold on. No, we're not going to do this one. I'm picking that one out because as I look at it, it's a really bad question.
Which
So-
statement is this?
Remember this and remind me tomorrow. Number 5, we're not going to do. Okay. Just as I read the whole question, it's very poorly written, so we're not going to do it. Do you guys remember your law of syllogism?
To cut or separate this one.
We have law of syllogism and we have the law of attachment. Okay. With law of syllogism, we take that, P implies Q, so P goes to Q, and then Q goes to R, so we just take Q out. Okay, so if I go to work, then I earn money. If I earn money, take the I earn money parts out and go straight from, if I go to work, then I buy stuff. So we can connect, if I go to work, then I buy stuff. We just take that middle guy out. Law of detachment says if P, then Q, and then I say P, and so I conclude Q.
So it's like
So
opposite.
if I go to work, I earn money, I go to work. So P, Q, P. So my conclusion, I have money, or I earn money. So the law of syllogism takes out the repeating middle guy, and the law of detachment says if something, then something else, and then I say that the first something happened. And as long as I say this first something happened, we conclude that the second thing happened. Yeah. If I say, if I go to work, then I have money, I have money. It doesn't necessarily mean I went to work, right? I could have money from something else. I could have gotten a birthday check, or maybe I won the lottery, or maybe I was already independently wealthy, so I didn't have to go to work. Wouldn't that be nice? Anyway. But, so you can't, if you have the conclusion here, you can't assume that the first part happened. The conclusion doesn't mean that the first part happened, but if you have the first part there, you can assume that the conclusion happened.
So
Does that make sense?
conclusion P?
The conclusion is Q.
Okay.
You conclude Q. So you say that if, so like, if I go to the beach, then I will get sand in my flip-flops, right? I go to the beach, so we conclude I get sand in my flip-flops. Whereas if I said, if I go to the beach, I'll get sand in my flip-flops, I have sand in my flip-flops, that doesn't necessarily mean I went to the beach, right? I could have gotten sand in my flip-flops from my yard, right? So you
Say
have
the
to say the
first
first
one
part again. If I go to the beach, then I have sand in my flip-flops. If I say, my next statement is, I go to the beach,
Okay.
then I conclude that I get sand in my flip-flops. If my next statement is, I have sand in my flip-flops,
Then you conclude.
I can't conclude that I went to the beach, because there could have been other ways to get sand in my flip-flops.
Technically, your statement should say the first, and then your conclusion should say the second.
You say the first and then the second, and then you say the first thing again. As long as you say the first thing again, then you conclude the second. If you say the second thing, then you can't make any conclusions.
Alright, say that one more time. If you say the first thing.
So you say the first thing to the second,
Okay.
and then you have to say the first again, so that you can conclude the second.
And that's detachment?
Yeah, that's detachment. But if you say the second thing instead of the first thing, you can't make any conclusions, because other scenarios could have happened that caused the second thing
Okay.
that weren't the first thing. Does that make sense? Like, okay, if you study for your test, you'll get a good grade. You got a good grade on your test. Doesn't really
Doesn't
mean you
mean you
studied.
studied.
Yeah.
Alright.
Does that make sense?
Yeah.
You might have just gotten a good grade without studying.
Could have winged it.
Yeah. So you have to say first, second, first. It has to go in order. So first, second, and then second. Not first, second.
And if it is first, second,
Then you can't make a conclusion.
it's a syllogism?
No, if it's first, second, there's no conclusion.
No conclusion?
Yeah. So if you say, if you go first, second, there's no conclusion. Good?
Yeah.
Okay. All right. Oh, what? Hold on. Yes.
About law of syllogism.
Syllogism.
When you talked about like you cross out your P,
You cross out your Q.
Right. So what if like it's one that's like PQPR,
No,
then what would
we
you
can't
write
do,
for that?
we can't, then you would just say there's no valid conclusion.
Okay, no
It
problem.
has to go P, Q, Q, so that you can cross out the two matching ones.
And when you're labeling those, P is always first.
P is
the
always
part.
first. Yeah, so the first part will be P and then the second part will be Q. And then if this
So-
part repeats, it's Q again.
So is P always the if sentence and Q is the then?
Yeah. Except for in the second sentence, the Q becomes the if. But it has to match. If it doesn't match, you can't cross this out. If you can't cross this out, you don't have a valid conclusion.
Okay, cool.
Okay, we have a couple properties. We had the reflexive property. You guys remember what reflexive is?
When
It's the same on both sides, right? So A equals A.
it's a metric would be
Symmetric is when it flips around.
it's like B
So
equals
x equals 3, 3 equals x. So you rotate around.
A. Okay.
Gonna put I suppose I could show them that they were being too loud, but it probably won't do any good. Okay, so reflexive is exactly the same on both sides. Symmetric, you just flip around. And then you had transitive.
Transitive.
So I have, oh, hold on. X equals 3 and 3 equals y. And then x equals y. And the way you know it's transitive,
Because that's that and.
the and with both, the and surrounded by the same thing on both sides. That's transitive, that tells you transitive. Okay, and then we take that red part comes right out, and you get the ends pushed together.
Right, I cancel out and we have x equals.
And then we have substitution, which is kind of similar. Remember I said I don't take off points if you confuse these two because they're so similar, but I just want to go back over them. So this would be like if x equals 3 and y equals 3, then x equals y. And the way you tell the difference is this is 3 and y. It's not 3 and 3. Does that make sense? So that's the difference between the two. But yeah, if those two became confused, I would just say, hey, this one is better as transitive, or this one is better as substitution, but I'm not taking off points for that. We also had, nope, that's all. Okay. All right, so that's the review stuff so far. Any questions on that? Okay. Then we have, anybody still writing?
How is
Transitive different from substitution?
yeah, they're the
3
same.
and 3.
You have and then y equals
3
3.
and
Y
y.
equals 3.
But couldn't you like, since y equals 3, couldn't 3 equals y? 3 equals y?
That's why I said they're so similar. I'm not going to count off if you confuse them, but transitive has to be in this order. That's transitive. If it's not in that order, it's substitution. Yeah.
Then so will the 3 still cancel out and equal x equal y?
Well, you have x is 3 and y is 3, so I take the 3 out and put the y in. That's the substitution.
Okay.
With transitive, I take this middle part in red and I throw it away. With substitution, I'm taking the 3 out and I'm putting the y in.
What was the other 3? Goes out 2.
Huh?
The 3 goes out 2.
Yeah, the 3, because both x and y equal 3, I can substitute things in.
Okay.
So I'm taking like a 3 out and I'm putting the y in. It's kind of like if you need change for $1, I give you $1, you give me 4 quarters, it's the same thing. Nothing changed, the value is the same. I just took the picture, right? The picture of the value. $1 looks different than a quarter, or y looks different than a 3, but they're equal. So I take one out and put another one in.
Okay.
Does that make sense? But like I said, they're so similar, I won't count off. But there is a difference, and the only difference is that the transitive has to have the same thing on both sides of the A. It's a transition because we go X to 3, 3 to Y. So we transition through 3, whereas here we take 3 out and put Y in. So it is slightly different, but just itty bitty bit different, not hugely different. All right, then we get to which angles are alternate interior angles?
Alternate interior angles would be like 3 and 6.
And
5 and 4.
Oh, 5.
1 and 8.
And then exterior would be 2 and 7, 1 and 8.
Second would be 3 and 5. 1 and 6.
Then corresponding would be what?
2 and 6.
2 and 6.
4
1
and 8. 3 and 7.
hold on. You guys are talking faster than I am. Right. 2 and 6. 3 and 8 and what? Or no, you said
3 and 7.
3 and 7. Okay.
1 and 5. 4 and 8. Can you still count the same?
That's
the
all
same
4 of
square?
them. Yeah, no, that's all. That's all
Okay.
4. Okay, so we have alternate interior, alternate exterior, consecutive, and corresponding.
And then supplementary angles would be the same as like corresponding, right?
Yeah, no, corresponding aren't consecutive or supplementary.
Okay.
So what we have is those 4 guys are all the same. And these 4 guys are all the same.
Right.
And all of the reds and the blues will add up to equal 180.
So could you do like 1 and 2 to equal 180?
1 and 2 equal 180, 2 and 4 equal 180, 2 and 8 equal 180.
Okay. So you
Any
could-
red with any blue will equal 180.
Okay, gotcha. I thought it was supposed to be within that square.
Now, the fact that these are consecutive, the 3 and the 5, the theorem is that, or the postulate is that 3 plus 5 equals 180.
Okay.
But that doesn't, because 3 is equal to 2, 6, and 7, and 5 is equal to 1, 4, and 8, you can now switch them out and rearrange them. So any red plus any blue will equal 180. Okay, if I have a more complicated, any questions on this? Hope? Let's say I have a more complicated picture. Let's say I have 2 parallel lines here with this transversal, and then these 2 lines are parallel, so this will indicate that those 2 are parallel, and this indicates that these 2 are parallel. Excuse my bad triangles. How would we pattern this? So I've got the 1, 4, 5, and 8 from this set. But then when I come over with this set, because these 2 lines are also parallel, I can continue the pattern. So 1, 4, 5, and 8 because of transversal, say, there's another one. Transversal M. And then 9 and 12 added with the 5 and 8 because of transversal Q. And then I get 2, 3, 6, and 7 because of transversal M. But then I can add in 11 and 12 because of transversal Q. And if I bring these lines out, they keep going forever. And I bring in another transversal that is not parallel to these two lines over here. And I give these some numbers. Okay. Now, across, if I call this line P, across P, P is a transversal still between line R, between line R and line M, but line R and M are not parallel. So 1 and 16 would still be alternate exterior, but they're no longer congruent. Okay. So 13, 16, 17, and 20 would be congruent because P and Q are parallel. But they're not going to be congruent to 1 and 2 and 3 and 4 because M and R are not parallel. Okay. So you're going to have, in this instance, two different sets of congruent things. You only have these over here that would be congruent to each other, and then you have these over here that are congruent to each other, but the ones on the left are not going to be congruent to the ones on the right because M and R aren't parallel. Okay, so just be sure to like analyze your picture and make sure that all your lines are parallel before you start deciding which angles are congruent.
But they still are like alternate.
Yeah, but 1 and 16 would still be alternate exterior, and 3 and 14. And then 2 and 15 would still be alternate interior, and 4 and 13. And then 2 and 13 would still be consecutive, and 4 and 15 would still be consecutive, but they no longer have the properties of being congruent or adding up to 180 because they're not parallel. Parallel is what makes the pretty nice, everything matches, you know, and adds up nicely. If they're not parallel, that's not the case anymore. Okay, any questions on that? Okay, and then I might ask you things like, well, if angle 4 is 60 degrees, what are all the other angles? I would ask you one specific one, but we can just go ahead and do all of them.
1 is 60, and that's 180, so that's like 120.
So what other angles are 60? And
9 and 12. And 120 is 3, 4, 6, 7, and 11.
and then I could come over here and I could say that angle 17 is 110. So what are all those angles?
Brown is going to be 70. And the green's going to be 110.
Put that now, please. Okay, so any questions on that? Or is that okay?
So far, you.
Alright, if I say line M is parallel to line N and line P is parallel to line N, what are line N and P to each other?
Parallel.
they're also going to be parallel, right? And if I say line M is parallel to line R, and line R is perpendicular to S, what are M and S? Perpendicular. Okay, so if two lines are parallel to the same line, they'll be parallel to each other. If two lines are perpendicular to the same line, so both of these lines are perpendicular to S, they'll be parallel to each other. Or if two lines are parallel and one's perpendicular to the line, then it'll be perpendicular to the other. Yes?
I don't really remember what perpendicular is.
90-degree angle. So parallel has the same slope and they never touch, right? Perpendicular cross at 90 degrees. They make right angles.
In between M and P, is that
Parallel. That's just a blank space. So it was like fill in the blank kind of thing.
Oh, okay, and then there's just a line underneath it.
Yeah, that was
Okay.
kind of my blank. I'll erase the blank. I'll make it easier. Better? Okay, so lines that are parallel to each other are either parallel or perpendicular to the same line. Lines that are perpendicular to the same line are parallel. Okay, so if you have to draw pictures, you can draw the pictures. Any questions about that? Okay, so I have two parallel lines and I cut them with a transversal. And I say they form alternate interior angles or something like that, okay? And I say that I want you to tell me what has to be necessary in order for these two lines to be parallel. What requirement would I have of these alternate interior angles for these two lines to be parallel?
Supplementary. Corresponding?
Okay, repeat the question one more time.
Okay, you have two lines.
Uh-huh.
Let's just say M and N. And they form alternate interior angles.
Parallel, postulate?
Okay, hold on. What has to be true? What has to be true about these angles for M and N to be parallel?
They have to equal 90 degrees.
Equal 180.
Alternate interior angles. What do we know about them if the lines are parallel? If the lines are parallel, what do we know about the alternate interior angles?
Parallel.
They're the same.
Perpendicular.
They're one and the same. They're congruent.
Okay.
So if the lines are parallel, the alternate interior angles are congruent. So if we have alternate interior angles, they have to be congruent in order for the lines to be parallel. We can go both directions, right? Parallel lines give us congruent angles give us parallel lines. So in order for this to be true, that M and M are parallel, 2 has to be congruent to 6, or 5 has to be congruent to 4. We need at least one set of those to be congruent. Okay.
You only need one.
And now if I had given a problem, let's say I said that 6 was 5x minus 3, and 2 was 3x plus 5. And then I could say, what does x have to be for M and N to be parallel? Well, 2 and 6 have to be congruent, right? So I would have to set these two things equal to each other.
What was the question? What does X have to be in?
Yeah, what does X have to be?
And when, like, say they were next to each other, then that would be supplementary.
Yeah, if they were right next to each other, if I said like 6 and 4, then they would have to add up to 180. But, so I can solve this. So in order for M and N to be parallel, X would have to be 4. That would have to be the value that would make it true. If X is anything else, then they're not parallel. Because then those two things aren't equal anymore, right? Everybody got that? Okay, complement adds up to what?
0.
And the supplements add up to okay, so complements add up to 90 and supplements add up to 180. And so if I said something like the supplement of A is 4 more than twice. What's the actual word? Okay. The supplement of A is 4 more than twice the complement of A. So we had to figure out the supplement of A. If we have supplement, so that's going to be angle A plus something equals 180, correct? So this supplement is going to be 180 minus angle A. Does that make sense? Because the angle A plus whatever its supplement is, just, I don't know what that is, so I'm just leaving the box right now. Would add up to 180. So what's in the box would be 180 minus A. Does that part make sense so far?
I thought it was going to be more than twice.
No, this is just a supplement. I'm just trying to show you how to set up a problem like this. So the supplement is 180 minus A.
If the supplement of
No, ignore this right now. Ignore all this. This is just if we're talking about the supplement of A. Just the supplement. The supplement is 180 minus A. Right? Because A plus the supplement add up to 180. So to find the supplement, we're going to do 180 minus A. So then the complement becomes 90 minus A. Okay? So we now know what the supplement is and what the complement is. The supplement is 180 minus A, and the complement is 90 minus A. Okay? The supplement of A, so 180 minus A, I'm just going to use an A, is means equals, 4 more than twice the complement of A. Okay, 4 more than 2 times the complement of A.
Oh, okay.
Do you see what I mean? Why I did this part first? So the supplement of A is 4 more than twice the complement of A.
So then you do like
2 times 90 is 180 minus 2A. get that too. So I get 180 minus A is equal to 184 minus 2A. I'm gonna run out of room. Here, I'm gonna move it. I moved. Do you need me to go back? Are you sure? Okay. So 180 minus A is equal to 184 minus 2A. So I'm going to move the 2A over here so it's positive, because I like positives. So 180, well, okay, 180 plus A is equal to 184, right? Because negative A plus 2A gave me A. I guess I'm going to switch function. So I'm going to subtract 180. So angle A is little a b thing, 4 degrees.
How come you kept it was minus?
How come it would be 3A?
180 minus A
Oh, okay.
plus 2A. So minus and plus cancel each other out.
Where'd you get the minus from?
Supplement is 180 minus A.
Right, so,
Remember, back here, hold on. We said that the supplement, to find the supplement, we do 180 minus A. Because A and the supplement add up to 180, right? So to find it, you subtract. So 180 minus A, that's the supplement. And then the complement was 90 minus A. So here's our supplement, 180 minus A. Here's our complement over here, 90 minus A. So the supplement, 180 minus A, is, that's the equal sign, 4 more than, that's 4 plus, twice, so 2 times the complement, 90 minus A. Then you distribute the 2. So you get 4 plus 180 minus 2A. 4 and 180 make 184. See, none of this changed yet, that's still just the supplement. So 184 minus 2A came over here. So I added 2A to both sides to get rid of that. Negative A plus 2A gave me the A. So then I subtract 180 from both sides to get the 4. So A would be 4 degrees. And if you want to check it, the complement is going to be 90 minus 4, which is going to be 86. And the supplement would be 180 minus 4, which would be 176. I would say 86 times 2 plus 4. Those match. So I know I got it right.
Your 2 would be twice the number?
Hmm?
To use 2 as like twice the
Because
number?
it's twice the number, yeah. So I can check it that way by taking the complement, multiplying it by 2, and adding 4 to it and see if they match.
In other problems like that, is the complement and supplement always the same?
The complement and supplement aren't the same. Oh, I mean, will they always be 180 and 190? Yeah, or and 90? Yeah, because there's always 180 to make a supplement and 90 to make a complement. I'm not doing 16. So we're at 5, 12, 13, and 16 that we're not doing.
20 questions?
Out of 26.
We're down to 22.
Okay, we have distance formula. Do you have a distance formula?
Square root of
Oops, that should be a y. Okay, so if I have 2 points, and I want to find the distance between them, squared, 7 squared, 7 squared plus 7 squared, 49 plus 49. So I have the square root of,
98,
yeah, 98.
and then you want us to calculate out the distance in decimals.
Eh. No, we square root of 98.
Or
Okay.
do you want us to see if we can pull it down?
No, you can leave it at that.
Okay.
They're not multiple choice. So that's one way we can work distance formula. Everybody got it? Don't forget to leave the square root on.
And the midpoint is x minus x. Or is it x plus x?
X plus x divided by 2 and then y plus y. Everybody got it? What if I tell you the distance is 10? And I tell you that your points are
I'm sorry, what was the midpoint thing again?
Alright, so we have our distance formula. Okay, I know that the distance is 10. X1 is 9. X2 is x. 3 minus -5 squared. Get rid of the square root. I square both sides. So 100 is equal to 9 minus x squared plus 3 minus -5 is 8 squared. So I'm going to do 8 squared first.
So that would be algebra 2 right there, right?
No.
No? When you square the distance, you have to get rid of your, right?
That's algebra.
Algebra, okay, okay.
So to get rid of the square root, we square it. The squares and square roots are opposite. Ignore, don't do anything with this right now. Just square the 8.
So when you square both sides, you get rid of the
Square roots and squares are opposite, so they cancel each other out.
Alright.
So square the 8, or whatever number you get. Subtract it from both sides. And 100 minus 64 is 36, which is perfect square. You guys agree? 36 is perfect square? Okay. Whatever this is, don't mess with it.
Or whatever that is.
Yeah, don't like multiply it out or square it or anything. Just leave it as a square, because when you get this number alone, you're going to take the square root of it. And the square root of 36 is 6. And square roots and squares cancel each other out. So you get a nice, pretty equation that's easy to solve.
You got 36. Okay.
So you get -3 is equal to -x. So 3 is equal to x.